Hey, hi, good morning, everyone. Let's wait for another 4 5 minutes. Seems like more people are joining, and then we'll start with the session. Hi everyone. Let's start. So I think in the last session we covered a couple of. I think we covered. Let me just open the doc. Give me a second. So as a part of the last session, I can see that we have covered e-commerce system design and hotel management system design. I hope I'm audible to everyone. All of you can hear me very clearly.
Yeah, we can hear you.
Oh, great. So we'll start with a new design question today. Let's try to solve. Why don't we try a parking lot system design today? So let's try to take some requirements as a part of this design. And this is not an online system. This is like you are actually designing a complete parking lot, and how will actually how what are the different uh, different entities, different actors, different use cases, and based on that we'll try to come up with a parking lot system design. This is one of the very famous questions which is asked in a lot of system design questions, a lot of system design interviews, especially the ones where you have to give the low level design interviews. So let me start sharing my screen.
Prakar, last week we talked about the blogging
Yeah.
design.
So
You wanted to,
so basically we'll cover this first, and then we'll talk about that blogging application
yeah,
system
sounds good.
design as well.
Yeah,
So let me know once you can see my screen. Okay. So let's start with the parking lot design. As a part of parking lot design today, let's start taking the requirements. So what are the basic requirements which we need to design for? So let's start with the requirements part. The requirements, what all use cases do we want to cover? So we can say that there will be a multi-level parking. Basically, you'll have multiple levels to actually park a car. Correct? Multiple floors, you can say. Parking of the vehicles can be on any of the floors. There can be multiple entry and exit points. So we can say that multiple entry and exit points in the parking lot. What else? We say that vehicles to be supported. We can say two-wheelers and four-wheelers. So we can say bikes and cars. That is what are we supporting as a part of this design.
count
And
of vacant spots.
yeah, so basically we'll have to figure out. So there should be a way to figure out if the parking is full or not. Correct. That is the main aim, right? Like, we'll come to that, or basically figuring out GMT slots. Then we can say that there should be ticket issue at entry point, and charge person at exit point. Correct. And we are supporting different payment methods for the payment. And yeah, so basically what we are doing is if the parking slot is full or not, and parking is full or not, and figure out we can track this up. Figuring out empty slots, basically status of each of the slot. Correct. Then we should have the notifications to at entry and exit, entry and exit of the vehicle. Let's try to understand what are the different actors as a part of this design, system design. So let's start with some of the actors which we have. So we'll have owners, we'll have customers or drivers, correct? So we can call it as either owners or customers or drivers, whatever we want to call it as. Or we'll have a parking attendant, then we'll have an admin. Admin will have their own specific roles. Now, what are the different use cases? Let's start thinking about each of the use cases which we'll have. So for the use cases, can we say that we'll have to park a vehicle? That is the basic use case, correct? Then we should be able to issue ticket for parking, correct? So basically, we have already taken a couple of requirements. Issue ticket for parking, figured out a couple of use cases. Park, issue ticket. We should be able to scan ticket, correct? There should be payment. There should be notification. Yeah. Now basically, because it's a basically there will be some system which will be figuring out how many slots are empty, how many slots are there. So we should be able to add, remove parking floors. We should be able to add, remove parking slots, correct? And we should be able to support different vehicles. And correct. So these are the basic details which you are supporting, right? Anything else? Multiple exit and entry points. This will be an interesting one. Like, how will you support the multiple entry and exit point? This becomes much more easier if you have just one entry point and exit point. But if you have multiple points, then how will you support it? These are the use cases which we have. Now let's start with the classes and entities for this. So let's put down classes and entities. But I'll stop here. If there are any questions, then yeah, please do let me know.
Attendant should be able to check the uh, free parking slots, right? And
So that we have mentioned, right? I mean, that will give status of each of the slots. So they'll know that which of the slot are empty.
we
Okay, so
need
we
to
can
maintain
mention.
a do we need to maintain a rate table as well? I mean, where we'll mention,
Not required. Not required.
I mean, based on hours, we'll be charging, right?
So that we can rate table you're saying. Rating table you're saying. Okay, sure. That we can maintain.
Rate.
Yeah, correct. We can do that. So we can have rate for parking. Mention rates. Let's talk about classes and entities. So I'll start with a very basic one. So let's say we can have a person related entities. Let's talk about all the person related entities. Yeah, I want all of you to give it a try once. What are the different person related entities? I'll give you 5 minutes. Try to figure out all the person related entities because this is very important. Now you should be able to figure out this on your own. So, I mean, it's fairly simple, right? You'll have, okay, I'll wait for some time. You can try it once.
Here's a Word document link, please.
Sorry, can
Can
you come again?
the Google Doc link.
Word doc link. Yeah, I'll do that. I hope all of you have access to this document. If anyone of you doesn't have access, then please do ping me your email ID. I'll just whitelist them.
So Prakar, usually the parking lots, I mean, we don't, user could come in, park and go away, right? So there's not a lot of customer info that is saved. So are we kind of assuming that it's, they kind of pre-register the customers, like say a monthly customer wherein system would have customer details?
You can do that, but you really don't need to complicate it. You can simply ask for the information about the driver and the license when they're actually, entering the parking slot, and you can save it. And basically, you can have a search based on their phone number or license ID. If you see that again, then you know that's the same customer. The problem is that one driver can actually come with a different cars as well, right? So, I mean, why do you really care about those details? This
Right. I
information
mean,
can
so the reason I got this question is because if you go into the parking lot, right? So don't think they'll ask any of the driving license and things like that. So it does not looking practical. So I was wondering.
Correct. So yeah, that depends, right? So if they might not ask you the license number, but they might ask you some. I mean, you can skip the driver completely. You can skip that class because you don't need, and we'll store the vehicle details. That is something which is automatically stored, right?
Right.
So we'll have a vehicle related details, like we'll have a vehicle, basically the registration number, and then we'll have vehicle type. We don't need a driver here. If you want, you can store some of the basic details about the driver, and they can register, for the parking slot before it. Otherwise, you can skip the driver class. So it depends on the interviewer, right? If they ask for these information, then you can store it, but it's not required. So if you like you'll see when I'll create a class, you won't actually collect a lot of information. I mean, you can collect those driver information. You can create based on the license or name if you want to store some details. And understand that, I mean, just consider that we are trying to create a very sophisticated model where we are storing everything so that there is basically we have the driver information we can associate it with the vehicle, but not really required. You can skip that as well. Okay. The other important part is basically, the parking attendant and the admin. Those are the two very important, and you will see that as well. That will be reflected in my design as well. I won't have any account related information for driver. It will be a very basic information if at all I collect those information. Okay.
Akhar, can you provide me the access? I have pinged you the email ID.
Sure. Cool. So let's start looking at. I'll give you one more minute. I've given you the access. So yeah, let's come to the classes and entities. Let's try to see what are the different classes, person-related classes we want to create here. So you can start with the staff class. So we have staff. The staff, what will have is staff ID. We'll have the name of the staff. We have their contact details. We can have their address. Then for each of the staff, we'll have an account, right? So can you see that we'll have account. This will have an account ID, username, password. Maintain the account status as well, right? If the staff is already, I mean, if this account is active anymore or inactive. And then we'll have the account ID as a part of this table. So will be the staff related details. And then what we'll have is we'll have a parking attendant. They'll have specific methods that will be inherited from the staff class, and they'll have specific methods which they can also issue ticket. And once they issue the ticket, at this point, the slot will be assigned to you. And they can scan ticket. At this point, the amount will be owed to you, right? And then they can process the payment as well from their side on behalf of customers. These are the 3 separate methods which actions which a parking attendant can take. And then you have admin, which is again inherited from staff, and they'll have their own method, cutoff methods. They can add parking floors. Just 1 second.
We need to keep a role table as well, right?
You doing okay? So we can do add parking floors. Then we'll have remove parking floors. Then they can add slots. They can remove slots. So basically adding and removing parking floor and adding and removing slots are for the maintenance purpose, okay? These are not for the purpose where, you know, the car is occupied or if the floor is the completely filled. That's not the case here. This is basically if they want to put it on the maintenance phase, then they can actually add or remove the slots. They can add and remove them. Okay, so these are the details, and then we can create a driver. As I told you, this is not required, and we won't have any driver uh, information here. So we'll have license number if you want to keep it as, have the name, and you'll have their phone number. Why do we require this? Because we might want to send the notification, and that is the only reason why we are maintaining this information for the driver. Okay, and we got a parking related details. Then we'll have what vehicle related details. So, I mean, I won't give you extra time for this. This is very fairly simple. So let's figure out this together. Fairly simple ones. We'll have vehicle related details. What all things we'll have in the vehicle? So we'll have a vehicle class. We'll have vehicle registration number. We might want to associate it with the currently like in the system. These are just the classes. This can be removed after a time. We can associate it to a particular phone number. Correct. So that we can send the notifications, and then we'll have a vehicle type. The two-wheeler or a four-wheeler. This is my vehicle entities. And then you'll have some address related entities, right? Because you have taken address. So I'm not drawing that, but you already know, right? What all things do we take as a part of the address? Correct. Now the main thing is the parking related entities, right? So can you start figuring out the parking related entities details? Like what are the different entities you'll need there? Again, I'll give you 5 minutes to figure out all the details on this for the parking related entities. So for sure, we'll have parking lot, parking floors, slots. I'll stop here. I'll give you 5 minutes. Try to figure out because there are a bunch of things here, and you can always take a look at the. Basically, you can take a look at our use cases, and based on that, you can design all the parking related entities. So try to come up with all the parking related entities. Okay, so let's try to start listing down all the details which you can think of. So basically we'll have a parking lot. So let's put the parking lot first. In the parking lot, what all details we'll have? We'll have a parking lot ID. Correct. We'll have an address at which this parking lot belongs to. Correct. There can be multiple parking lots. Then I'll have the list of parking floors here. And we'll have a list of entry points in this parking lot. And we'll have a list of exit point. Correct. And we'll have some methods like is parking full. Then we'll have add floors, remove floors, which can be called only by your admin. These are the methods of the parking lot. Then we'll have a parking floor. So you see that we have a parking floor. In the parking floor, what we'll have? We'll have a parking floor ID. We'll have the list of parking slots here. List of parking slot. And is parking slot available? We'll have a slot type. Basically, which of and get all parking slots available. This is again based on the slot type. Slot type means whether it's a two-wheeler parking or a four-wheeler parking on that parking floor. Now we'll create a parking floor parking slot class, and this will have a slot ID. We'll have slot availability status. What are the status we can have available? Occupied. Right? Can have a slot status, whether it is under maintenance or it will be available. We should have this in the floor as well, right? Floor status. Okay. Slot status. Is there anything else which you need to store? Slot type, we haven't stored the slot type. It's a slot type, whether it's a two-wheeler or a four-wheeler. Then we'll have update availability status and update slot status, or add slot, remove slot. Simple. No, add slot, remove slot won't come here. Add floor, remove floor, and then add slot, remove slot. And then here we'll have update slot status. Similarly, we'll have update floor status here as well. Correct. This is for the parking slot. Now we'll have the entry point and exit points as well. In the entry point, what we'll have? Entry point ID. We'll have ticket issuing machine. And we'll have assign ticket method, which will call the ticket issuing machine and assign the ticket to it. And then we'll have exit point. In this will have exit point ID. We'll have ticket scanning machine. And we'll have scan ticket. And this will ticket scanning machine will return you what? This will return you the price, the amount to be charged. This is my entry and exit point. Then we'll have a parking ticket itself. Parking ticket will contain what? Ticket ID, a vehicle ID for which this ticket has been issued. We'll have a floor ID. So this is assigned, right? Floor ID is assigned. Slot ID is assigned. Correct.
Machine
In
ID
time.
from which the ticket has been issued.
You don't need to. Why do we need those details?
Identify which particular attendant might be operating that machine, so that.
But why do we need that detail? We don't need that, right? I mean, it's the exit. So why? I mean, there is no use case to actually have it. I mean, I can't think of a use case why we should have it. That information is not adding any value. I mean, if you want, you can keep it, but you don't need really need to actually have that information to be captured. I mean, all the information which you have written, see, we need to know the ticket ID, we need to know the vehicle ID, we need to know the floor and the slot which has been assigned. We need to know the time at which they entered, and we need to also, I mean, we don't need to know the exit time because that is something which is not captured in the parking ticket. I don't think we need any other details apart from this. I'm trying to understand why were you mentioning. I mean, you can capture it if you see there is a requirement, but I don't see that as a requirement right now for our current design. Okay, so we have a parking ticket, and then we'll have a ticket issuing machine and ticket scanning machine. Right? So ticket issuing machine will have what? Assign ticket method. It will take bunch of parameters, and based on that, it will assign the ticket to you. And then there is a ticket.
Prakash, sorry. Don't we need to capture the entry point ID while we are issuing the tickets?
Why do we need to? That is what I'm trying to understand. What? Why do we need to capture that information?
We are going to trace out which particular entry point that particular customer has entered.
Why? I mean, why do we need to trace that? Like, what is the use case of that? We are just supporting multiple entry points, but why do we need to capture that? Okay, what is the requirement for that? Do you see any requirements? Like, why do we need to capture that, from this particular entry point the person has entered? Okay, I mean, if you can see a use case, we should definitely put it. But I'm trying to understand, like, why do we need that? Are you getting my question?
Yeah.
I mean, I really don't see a use case. Why do we need it? We are just assigning a ticket. I mean, they can enter from any of those points. Right? Why do we need to capture these details? Because someone will ask for all the entry points and exit point for a parking lot, right? Then we should be able to display these are the entry point and these are the exit points. Correct. But we don't need it in the parking ticket, or ticketing machine doesn't even need to know about that, right? I mean, you can shift this machine to somewhere else. It should work as it is, right? We don't need to punch the entry point and exit point details there, right? Okay. So, I mean, I don't see a reason for that. I mean, if there is a use case to do that, then we can definitely store that as well. Then we have a parking rate. What all details we'll have in the parking rate? So we'll have a vehicle type. And then we can say minimum rate. And then we'll have hourly rate. And based on this minimum rate and hourly rate, we'll have calculate amount. We'll take the input as calculate amount. And sorry, the method is calculate amount. Based on the vehicle type and minimum rate and hourly rate, we can actually capture these details. And we can say that, I mean, we can display this and then finally calculate the amount and then return back to things. So these are my parking related entities. Can you think of anything else apart from this? I think I've captured all the information here. Now we'll have to design the payment related entities. Correct. So let's talk about the payment related entities. So we have sorry, payment related entity. So we can directly capture the transaction. What will have is the transaction ID. We'll have the ticket ID for which we are issuing this transaction. We'll have the amount, the transaction status. It can be pending. It can be completed. Correct. And then there is create transaction. We can capture the payment method as well if you want to. Correct. It can be payment method. It can be cash. You can select this option, right? Or UPI, or you can have card, whatever. And create transaction, and then update transaction status. That's it. We can have the timestamp as well, right? At which this is done. These are the details that you're capturing as a part of your transaction.
After the transaction status can be filled as well, right?
It can be filled.
And in which case we will use this object update transaction status?
So basically what can happen is that you carried out automatically what can happen is that, let's say this transaction. So generally the transaction table is, there will be a machine which will actually issue a bill to you, right? Like this, the final bill or something like that. This machine is attached. So basically, let's say you swipe a card. So it takes some time to process, right? So on the back end, we need to know what happened with that particular transaction. It could possibly fail for the same ticket ID, right? Let's say if you're doing a card transaction, it can fail, or if you're doing a UPI transaction, it can fail. We're trying to just capture those information. And if basically it is successful, automatically there will be some bank or someone will be calling this particular transaction, transaction class to update the transaction status. Understood?
Okay.
This can happen on the async basis, right? Let's say the transaction was started, but it is not yet finished. Correct? So on the async basis, this can be updated, right? That's what we are capturing. And then we'll have a notification related details, which I've already talked about in the previous sessions as well. We'll have a SMS. We can send a notification to the SMS. So we'll have a notification ID. Notification ID. What type of notification is it? It is basically parking, exit. If you want to have some other things as well, then we'll have timestamp, have content, we'll have the phone number to which this notification is sent. These are the details, correct? And yeah, so these are the details, and then there can be some system related entities, right? You can take the actions based on the system, like where we'll have the objects of all the above classes, and there is something called park vehicle or remove vehicle. Park vehicle will take input of the vehicle class. It will check if the parking is full or not. It will assign the ticket based on the parking lot ID, based on the entry point ID. It will update the sort status. It will send the notification. For the remove vehicle, what we'll have is, we'll know the ticket. So we'll scan the ticket. We'll update the slot status because the ticket has been scanned already. We'll create a transaction. We'll update the transaction status and we'll send the notification. So those are the system related entities if you want to draw it. But these are the main all the actors which you have listed down, all the use cases which you have listed down, all the classes and entities which you have listed down. And then we have talked about each of these entities. Now I want all of you to actually, I'll give you 5 minutes, and I want all of you to try an entity relationship diagram. It's not very difficult here. So I want all of you to try it for once, and then we'll discuss. You can draw it in your copy, and you can send me the screenshot, or even if you're not, taking screenshot and sending it to me, that's okay. I just want all of you to give it a try at least once, that how this entity relationship diagram will look like. And then finally we'll draw it, and then we'll move on to the blogging system design question. I'll give you 5 minutes. take your time, try to draw the entity relationship diagram, and then we'll discuss this. Okay. For parking ticket class, we don't have outtime. I have not kept outtime here, but because in the parking ticket you can't actually mention you have issued it in the parking ticket when you're entering, right? How will you update it? So you can, on the database layer, yes, you can update, maintain that, but there's more like a, as I told you, right, there's more like, these are more like a physical details which you are trying to store as a part of this. This is not a system. This is not a computerized system which you're trying to design. In that case, you'll have a separate parking ticket as an entity, and that's why I'm not capturing the outtime here. But if if you want to treat it as a digital one, then you can actually have the outtime list.
We have not also maintained the amount we have charged to customer with the parking.
We have
We
it
have just
maintained.
mentioned in the transaction statement.
Yeah, we are capturing it in the transaction, right? Hello. Yeah,
Yeah,
we are
got it.
capturing it in
Okay.
the transaction.
Got it. Prakhar?
Yes, tell me.
Yeah, I have a question. Can you go up, scroll up, please?
Yeah. Yeah.
When we have designed the entities, okay, we have in the with the staff parking attender, you have associated a method called issue ticket, right? So
Yes. Yes.
so this would be the action taken by the this particular fellow staff
Yes.
person, and
Yes.
uh, so so if we are designing the APIs, then there would be a issue ticket method associated with parking attender. Is that the
That's
thing?
correct.
And
That's correct.
then when you invoke this issue ticket method, there should be some physical ticket that needs to be issued, and that in the backend that would invoke one of the entities which you have mentioned. Assigned ticket is the method that you have mentioned with one of the entities, right?
That's
That's
correct.
correct.
So
So
basically
basically,
the
the
way
way
it
it
will
will
work
work
is
is
this
this
issue
issue
ticket
ticket
will
will
actually
actually
call
call
your
your
ticketing
ticketing
machine.
machine.
Your
Correct. So
So
this
voice
will
this
is
will
have
have
a.
a.
getting your voice is getting echoed.
Is it okay?
Okay,
Let me
let me
rejoin.
rejoin.
Is it
Is
the
it the
case
case
for
for
everyone,
everyone,
or
or
can you
can
all
you
Yeah.
all
hear
hear
it?
it?
Okay,
Okay,
let
let
me
me
rejoin.
rejoin.
Is it better now by any chance?
Yeah.
Yeah.
Okay. So let's go back to the design. Yeah. So basically the way it will work is here we'll have issue ticket, right? So this is my issue ticket. We'll have a ticket management object here. So basically ticket management object dot this issue ticket. Whenever the person is requesting for a ticket, whenever they're going to the entry point, at this point you'll have a this issue ticket will be invoked, which will actually call the issue ticket of this ticketing management system, ticket issuing machine. This will create a assign a ticket to you, correct? Once this ticket, this will give you a physical ticket, which will be handed over automatically to this and to the person, and then this will actually hand it over to the actual driver, correct? And same thing will happen at the station. You'll have the scan ticket. It will scan the ticket. It will call the ticket scanning machine, correct? So is a ticket scanning machine. Your ticket scanning machine will take and scan the ticket. It will calculate the amount for you. It will give back the amount to you, and that amount will be told by the person to the issuer. And then they will process the payment on behalf of the customer. So we'll have process payment as well here, if you'll see. So you'll have a process payment. It will take either the card or UPay or whatever they're taking, a card or cash, and they'll actually carry out the process payment method and finally update the transaction status and create a transaction from there. Understood?
When we are associating methods with an entity, okay, so
Yeah,
these are all the service these are all the services that is associated with that entity, right? At that
that's
service class.
correct. These are the actions, not we should not call it a service. These are the actions which this person can take, this actor can take. Understood?
Yeah.
Because this is basically your actor, right? See, this was my actor.
Now, if I talk about Spring, then issue ticket would be one of the methods on the some service class, and from there the several DAO class or any of the another REST API call would be made. Say, for example,
Exactly.
a ticket machine
Exactly.
would be ticket machine API, there would be some third party API that you might be invoking to get the ticket ID and all that, right? I mean, that is
That's correct. That's correct. So basically,
that is
these are more like APIs. These are, so as I told you, right, actors are the ones who are taking, the only ones who are taking the actions. And these other rest ones are the storage methods. I think I explained it this earlier as well, right? These are more like your methods that will
yeah.
go and check your database data if it is present or not. There is no as such database for parking attender, right? All gutter
No,
setters will have it on the staff table if you want to have.
no, but the other methods, the other methods you have, that add, remove floors, these are the actually CRUD methods that you're talking about.
Exactly. That's what
I
I'm
mean,
saying, right? These are the ones which are action-based methods because these are actors which are taking the actions.
another question
These
I
are
have
the
that,
yeah. Tell me.
sorry, God, sorry, my bad.
No, no, come ask a question. Go ahead.
My question was, we are not maintaining any roles over here in the staff or like that. How we are going to distinguish between the admin and the
These are the class, right? So when they're logging in, right? They're logging in will know whether it's an admin or the staff. I mean, it's admin or it's a parking attendant. Again, you're getting confused. These are not. See, you try to mix two things. These are not your database. This is not your DB database. This is your class. There's a difference between DB and class. So database will have that information. So database, if we'll create a staff, we'll have a staff ID, account ID, name, contact detail, address, staff type. But when we are returning this detail as a parking attender, we'll return this detail and we'll store it in the parking attender. These are my classes. These are not my databases. We don't need to maintain the staff type here because either we'll return a parking attender or admin. Are you getting my point?
got it, bro.
So did you understand the difference? These are the classes, right? These are not my why. I mean, because these are the classes, we don't need to maintain that because we won't return staff ever. We'll always return a parking attender or the admin object. If we're returning admin object, it's by default understood that it's an admin. If we're returning a parking attender object, then it's by default understood that it's a parking attender. Did you get my point?
Yeah, got it, bro.
Correct.
So
On the
you
database level,
you
on
are
the DB
already
level,
maintaining at DB level. That's why you're not maintaining it over here. I think that's what. Right.
no, there is a difference. DB will have only one class called staff class. Sorry, staff database table. Staff table will have all this information.
But there would
We'll
be
have
a
the staff.
staff type over there as well, right, brother?
Exactly. But when we are loading that staff type, if we know the staff type, we'll load it either for the as a parking attender or as an admin only, right? We are returning these objects, object of these classes. So by default, it is understood that when you're returning a parking attender, it will be a parking attender. We don't need to pass the staff type here again, right? For this object. Are you getting my point?
Got it.
Is it clear to everyone or you have any confusion? See, if any one of you have any confusion, then please ask. I can explain to you again. So at a DB level, we'll only have this table and we'll have the staff type. When we are loading these objects, we'll load it either as admin or parking attendant. And this is just this is not even your concrete class. This is your abstract class, correct? And this abstract class is this concrete class will inherit this abstract class in that case. And these are the methods which this a parking attendant as a parking attendant you can take, and these are the actions which as an admin you can take. I hope this is clear to everyone. If you still have any question, then let me know. We can discuss. Okay, now let's try to draw the diagram. The end-to-end, not end-to-end diagram, the entity relationship diagram for this particular design. So let's go back to let me share the XLE draw. I have pinned you one link. Who has drawn this? Okay. Cool. Let's try to, let me check. Yeah. Let me know once you can see my XLE draw screen. Okay. So what did we start with? We started with the staff, right? So first we had staff. So let's do this. We'll have staff here. The staff has an account, correct? So there is an account class, correct? Then staff can be either a parking attendant or it can be your admin, correct? Then we talked about vehicle class. Each vehicle will have a driver. Driver can exist without a vehicle as well, correct? One driver can have, can you please not move this? Why are you doing this? Who is this? Yeah. We have one driver can have n vehicles. We have one to one relation. Please don't draw it. I'll have to. Please don't do this. Who is doing this? I won't be able to. Uh, please don't draw anything. Whosoever it is. Wow. I'll actually create a new draw.
I don't think that the person who
Sorry. Sorry, can you hear me?
I'm saying that I don't think the person who is doing that is not doesn't belong to us.
But I don't know how the link is shared with the other person. That's not possible, right? Let me draw it. Let me give you another link. I'll just stop sharing. That's okay. Uh, okay, no worries. Could be someone. Okay. Can you see my screen? Yeah. So what you have drawn so far was, uh, yeah, we had staff, we had account, so we had account, we had vehicle, we had driver. This was one to n. One driver can have multiple vehicles. This is one to one relationship. We have parking attendant. And we had admin. Okay. So these are the details which you came up with so far. And after that we had parking lot. Okay, so let's go and draw the parking lot. What did we draw in the parking lot? So parking lot will have a parking floors. So can we say that parking floors cannot exist without a parking lot, and parking lot will have parking floors? And parking floors will have parking slot. And can we say that parking lot will have an entry points? And can we say parking lot will have exit point? And entry point will have ticketing machine, right? And ticketing machine can exist without even having the entry point. Ticket issuing machine. And can we say that we'll have ticket scanning machine as well? Correct. And one entry point will have one, this, correct. And then we'll have a parking ticket here somewhere. And we'll have a parking rate. What else did we have? We had notifications and transactions. Each transaction will have at least a parking ticket. So transaction will have a parking ticket. A contains B and B can exist without A, right? So without a transaction as well, a parking ticket can exist. We'll draw this.
Prakhar, what is this mentioned after this entry point box? It's not clear.
Ticket issuing machine. Let me write it again.
Yeah.
Let me see where is the. There should be eraser somewhere here. Is anyone aware of this eraser here? Okay. I'll write it again. Basically, what I meant was there's some. Okay. So what I meant here is there's my ticket issuing machine. Okay. Now what is happening here? Yeah, now this will fit. So we have a transaction and transaction contains parking ticket, but parking ticket can exist without a transaction. And then there are notifications. And now parking attendant can actually carry out a transaction. Unidirectional call. Correct. And we can say that admin can actually take an action on the parking slot. Admin can take an action on the parking floors. Admin can take an action on the parking lot. Correct. Parking attendant can actually call your ticket. Parking attendant can call your ticket scanning machine and it can call your ticket issuing machine.
In ER diagram, do we need to show the actions as well? I mean, it's just a relationship between the entities.
That should
right?
be okay. So see, these are unidirectional flows, right? I mean, this can call this. So I mean, it's better if you show this because we can say that we can show the action, right? Saying that parking attendant can take this action on this and can take an action on this. But I mean, the main part is this entity relationship diagram, how they are associated. That is at least which we require. But we can also show that how exactly these calls are made from each other. So these are the actions which you are taking, right? So the actions will be from these basically your actors always. Correct. So this is an actor, this is an actor, and this is an actor.
Now, in this case, in the between the parking ticket and driver, there is no relationship we are showing. I mean, there should be a
Parking
relation.
ticket
And
and
for
driver.
or vehicle, you mean to say? I mean to say, if there is a which
So we'll
particular
show that, right? So vehicle parking ticket will have the vehicle ID, right? So we can show that, right? So parking ticket will contain a vehicle ID. So we can show that relationship here. I've not completed it yet. Let me finish it first. So we have exit point, entry point. Now ticketing machine can actually get the ticket issuing machine can actually call the assign the parking ticket. We'll call this. Okay. And ticket scanning machine can call this, and it can actually scan the ticket again. Correct. So parking ticket it will take this as it, and it can call the parking ticket. And ticket issuing machine will actually assign a ticket. So there is an action from here to here, and there's an action from here. It will scan the ticket and it will take the parking ticket. So it will take this as an input, take this as input, give this as an output. And now vehicle is related with parking ticket. So each vehicle will have a parking ticket. So we can say that each vehicle will have a parking ticket. So parking ticket contains vehicle, but vehicle can exist without a parking ticket as well, right? And one vehicle will have one parking ticket, and one parking ticket will have one vehicle. These are all the associations which we have. Correct. Parking ticket will have parking floor details and slot details as well, so you can draw this as well. That's it. And one parking ticket will have one parking floor, and one parking floor can have n tickets. Same thing. One parking slot can have one ticket, and one ticket can have one parking slot. These are all the relationships which you have created. This is your entity relationship. Let me take the screenshot and paste it on the document. Okay. This is my parking lot design. Now, has anyone of you attempted the question which I gave you as a part of the last discussion, the blogging application? If yes, then can you share the document? I'll just take a look and we can discuss. Any one of you who has worked on that? Yes, no.
Yeah, did some work on that. Just share my
Okay.
notes here, at least on the estimates part.
Yeah. Whatever you have, you can share and then we can discuss.
Copying this from Excel.
I see. Okay. Let's see blogging application very quickly. We'll discuss on a very high level. So shall I just go to Accelerator and discuss it there itself? Because I mean, it will take some time for me to make notes. And if you want, you can take the notes. I'll write it here on the. I'll just clear this. I hope this is visible to everyone. So what are the basic functionalities we want to take as a blogging application? So basically, we definitely want there should be user, or basically there are two parts of it, right? The first part is the blogger part, and the second part is the reader part. Correct. So you have to design for both blogger and reader. Blogger can actually post blogs. They can see the views. Basically, they can see do analytics on the top of it. Correct. Post blog, they should be able to do analytics. And what else? They should be able to. I mean, there will be login registration for both. We'll say login registration for both. Correct. The reader should be able to read blogs. They should be able to like or comment on blog. They should be able to follow bloggers. Correct. What else? They should be able to do the analytics, the number of read has been done, the number of comments, and number of likes and comments on this. We have a blogger, we have a reader, we have post blog analytics. Let's say that we are taking these as a very minimal requirements. Now we'll talk about some of the estimations. So these are my functional. Non-functional requirements will be what? We'll prefer availability over consistency for sure. Availability, latency should be low. Correct. So I'm just writing it here. These are my NFRs. And we are saying that consistency, we need high consistency, but this is preferred over this. Estimations, we are saying that, let's say we have, someone has done some estimations. Let's try to see if what all they've assumed. I'm not sure how many users you have assumed. So let's make some assumptions. So let's say that on our platform, we have around 100 million daily active users. Total users are 500 million. Then we have, let's say, 10 million bloggers, which is a lot, to be honest, but let's start with those. You can start with 1 million as well. 1 million bloggers. Let's take 1 million. The 1 million, sorry. We have around 1 million bloggers. Let's design for assuming these estimations. Now let's design the tables very quickly. So we'll have table, we'll have a blogger table. I mean, basically a person table. This person will have all the details, username, password, and all those details. And finally, you can have type, whether it's a blogger or the reader. Correct. So this is my person table or user table, we can call it as. User is much more sophisticated. You'll have the user details and all those which you have listed down. So I'm not listing all those things here. Then after the user table, then we'll have the main important is the blog table. In this blog table, we'll have a blog ID. We'll have the name on the blog, name, or basically title. We'll have title. We will have, sorry, we'll have title. We'll have author who has written this blog. Then after that, we'll have, blog description, basically blog actual text. And then we can have creation timestamp. So these are the details which are actually capturing. And then we'll have the visits. Now we can have, the way we can keep visits is we can actually have a separate visit table for each of the day, or we can create a single visit table for the number of visits. So basically, whenever there's an impression on this blog, we'll actually count this. So there will be an API which will actually have, log visit on blog, something like that. So we can maintain a visit count here if you want to. It's better to maintain a per day visit count, so we can have a separate class for that. So we can say that visit count. And this will have what? Visit count will have what? I will have the blog ID. We'll have the date. Just the date. And the primary key will be what? Primary key of this will be blog ID, comma date. And then we'll have the visit count here. Total visit, number of visit. And then we'll have a reaction table on the top of this blog. In the reaction table, we'll have a reaction ID. we'll have a blog ID on which we are taking this reaction. We'll have the user ID who is actually making this reaction. It's a reaction type. It's a like or a comment. And if it's a comment, then comment text. Correct. Now let's do some estimation. So here, let's say if you have images as well, so this will be around 1 KB. Let's say it's a big blog and you might have some images as well. So we are assuming that on an average, this will be 10 KB. Reaction, we are saying that it will be fairly simple. So we'll say that it will be some 100 bytes. Visit count is nothing. We're storing 10 bytes per day. This is close to negligible. We can ignore this. Now we are saying that daily we'll have 1 million bloggers. Now the number of blogs per day will be, let's say that number of blogs, most of the bloggers will actually post. So we are saying that 500,000 blogs per day we are assuming on an average, or we can say that 100K blogs per day. This will be better. Number of blogs per day. Now if you have to do the estimation, let's start with the capacity estimation. Capacity will have, you have to store the total number of users. So how many bloggers? You have 100 million, 500 million total users, 1 million bloggers. So we can simply say that 100 million into 1 KB of data. This is for the blogging. Then we'll have blogs. So 10 KB of data per day, blogs, and 10 KB. And then there are 100K blogs per day into 365 days. So we'll put 400 plus. Then we'll have reactions on this blog. So we have 10K, 100K blogs per day. And let's say on an average, we'll get 10 reactions. Correct. And we won't get these 10 reactions every day, right? This will be for the first few days on an average, right? So 100K blogs per day, and we'll have 10 reactions. So let's say we can actually say that 100K blogs in total per day, and then on maximum reactions on each blog is like say 100. On an average, there are 100 reactions on each blog, and this each of is of 100 bytes. And we are doing it capacity estimations for next 1 year, so we can say that this will be into 400. Plus the visit count is what? So number of visit count. So we'll have to maintain a separate blog for each date. We'll have a blog separate table. So we have 100K blogs per day into, there will be 400 days. So there will be 400 entries, right? So for each blog, and for each blog, we'll have 400 entries. And in total, how many blogs will be created? Correct. Can we say that? So some blogs will have, like, there will be few blogs which will be created on day one. There will be few blogs which will be created on the last day of the year. So I'm approximating this to 200. Basically, each blog on an average will have 200 entries. Correct. If that is the case, and then there are, because there will be blogs per day, like every day we'll have blogs into 400 into 10 bytes. This will be negligible, to be honest, because this is 100K into 200 into 400 into 100 bytes is already coming here. So this, and then there is this as well. So 500 million into 1 KB will be what? You can say that this will be 500 GB plus 10 KB into 100K. So this will become what? So 1000, this will be MB. Correct. This whole KB and K will be MB, and this 1000 will be GB. So we are saying that 400 GB for this, plus this is my 100K. So this is, can we say that this is 100K? So these are bytes. Can we say that this is my 10 KB and this will be my 10 MB? Sorry, 1 MB. Right? 1000. So 10 to the, this is 1, 2, 3, 4, 5, 6, 7, 7 zeros, 8, 9 zeros, 10, 11 zeros into 4. 4 into 10 to the power 11 zeros. Correct. So this will be what? 4 into 10 to the power 11 is what? KB, MB, GB. So 400 GB for this as well. Correct. So we'll have 400 GB for this as well, approximately. Sorry. And this will be what? Again, right? This will be 4 into 2 is 8 into how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be approximately what? 80 GB. This comes out to be 500 plus 400 plus 400. So can I say that approximately 1500 GB, which is 1.5 TB over the next 1 year? Nothing, very small capacity which we have. to the QPS planning. Let's say that we have 100 million daily active users, so there will be read blogs, correct? So and each user is on an average reading 2 blogs. So can we see that mostly there will be read, that it's a read heavy system? You can clearly see that there will be a lot of read blogs. So can we say that number of reads will be what? Can we say that 500 million daily active users are reading at least 5 blogs a day? That will be divided by 10 to the power 5. This will be equal to what? Per second, right? So QPS will become what? 5,000 QPS, which you have to support. Now this is my read QPS. If I do it for write, then basically how many we have a reaction and we have this. So basically reactions and visit counts, right? So let's say if the number of visit counts will be 500 QPS, right? Because every time we are actually reacting on something, sorry, whenever we are visiting something, we'll have to increase the, so 5,000 QPS, that is at least we'll have to support for the write, plus what we'll have to support, we have to support the write as well here, right? So because there is a update on the visit count, and then there is a reaction. So can you say that on an average, each user is, there are 10 reactions per day on one block, and there are how many blogs are we writing per day? So where is the assumption? We have 100K blogs per day. So 100K into 10. So these are the reads plus 100K. Sorry, these are the writes of the blogs, and 100K into reactions, 10 reactions. So we can ignore this, right? So we are saying that total will have 10 to the power 6 of reactions, including reactions, will have 10 to the power 6 actions per day, divided by 10 to the power 5, which is equal to what? Nothing. Am I missing something here? 100 million, 100K blogs, 100 million, 5. This is correct. So this will be 10, correct? This is my 10 approximately. So this becomes 5,010 QPS. Why this is becoming very high QPS? Because, because of this visit count table which we are maintaining. We can do, what we can do is we can do the optimization. Instead of writing it every time, we can actually write it on in some cache itself. Instead of writing it into the DB, it will actually reduce your cost, and then after a point you can actually write it into the database. But the write QPS is very less compared to the read QPS. Now APIs, what all APIs do we need here? So we'll need a read blog, correct? We'll pass blog ID. We'll have a search blog capability. Based on the category, you can maintain the category and bunch of other details as well in the blog table. So we'll have search blog, read blog, then we'll have add blog, and we'll have login user, and then react on blog. These are the basic APIs which we'll have in this. For the sharding, you can do, now coming high level design will be fairly simple. You'll have two different client WebSocket, no WebSockets. It's a standard HTTP. You'll have web servers, you'll have application servers, you have database servers, you'll have load balancers in between. There will be two different clients. One can be for blogger, one can be for the user. You can or reader. You can have the same, you can create the same web servers, or you can have different web servers based on the application. That is something which I'll leave it up to you. There will be authentication, authorization. For sharding, you can clearly follow a strategy, because you can shard it on the basis of the. So I will always, you can easily shard it on the basis of, because there are very limited number of blogs, you can shard it on the basis of the user ID and do a consistent hashing. Shard the data on the basis of the user ID. You can have a master slave application to copy the data or blogs into multiple tables or multiple machines in the asynchronous way. So you can have a master slave configuration for that. And you don't need a caching. What you can do best, you can cache is, like, if there are there are some blogs which became very, very famous, you can actually cache those blogs here, and that is good enough. So there will be a caching strategy to cache the blogs. Authentication, authorization, you can, only the user who has actually, everyone who is actually reading the blog should authenticate into the system. They can't use our application without logging in. And authorization, we will have only the user who has actually written a blog can update the blog. So that is the authorization we'll have in this. And then we'll have a bunch of monitoring and alerting. This is a good enough example. So I tried to cover this in 20 minutes and talk about more things in details during the interview. But because you have discussed this in detail, like similar applications and details in past, I've just skipped. I wouldn't say skipped, but I've moved very quickly through some of these parts. So you can talk about this in the interview. If you have any questions, I'm happy to take that a question on the blogging application. I hope this was clear to everyone. It's not a very difficult design, to be honest. It's one of the simplest design because you don't have anything. I mean, scalability point of view, this can be tough because the number of bloggers are increasing, the number of blogs are increasing. So you'll have to increase that. But otherwise, designing the services and taking all the actions, I don't think it's very complex. Services are fairly simple. You'll have a user service, you'll have a blog service. That's it. Yeah, there will be two services, and then you can draw a high-level design for that. Okay, tomorrow we'll continue with a new system design question. We'll try to take another low-level design. As a part of the homework, I've given you what all questions so far: scalability, latency, partitioning. I'm just checking if is there any other question which I. Okay, why don't you work on this Instagram stories or Facebook stories which we see which disappears after 24 hours? I want everyone to actually work on that. So basically, you can add a story, and that story should exist on your profile for next 24 hours. This is the basic requirement. You can add some. I mean, you can add photos, you can add videos. Those requirements you can take on your own. There will be user. They'll have a login registration. So try to work on that high-level design, and we'll discuss that if the time permits tomorrow. Okay. And if there are no further questions, then let's meet tomorrow and have a nice weekend. Happy weekend. Thank you so much. I'll end the meeting now.
Yeah, thanks, Prakash.
Thanks. Bye.